Neil deGrasse Tyson here for StarTalk. Coming up, Brian Greene's latest book, Until the End of Time. Well, we don't know what that means, but we know what the subtitle means. Mind, Matter, and Our Search for Meaning in an Evolving Universe. Smackdown on StarTalk. Be there. StarTalk, Cosmic Queries Edition. Neil deGrasse Tyson here, your personal astrophysicist. And as is not always, but most of the time, Chuck Nice.
Hey.
Co-host.
Good to be here,
We
man.
just fist bumped in front of our guests.
Yes, we did.
That's rude. Is that rude?
Yep, there we go. Now we'll do a three-way fist bump.
Commutative property of fist bumps.
That's right.
Brian Greene is our guest.
That's right.
We're doing Cosmic Queries Until the End of Time. I didn't just pull that out of an orifice.
I was going to say.
It is actually the subtitle of
That's
his book.
the title.
Oh, it's the title.
That's the title.
Not the subtitle. What's the subtitle? Mind, Matter, and Our Search for Meaning in an Evolving Universe.
Nice.
That kind of means everything, right?
That is. But doesn't the universe automatically elicit questions of what is my purpose, my meaning? Why?
That's why we have him here to talk about this for the show.
Oh, cool.
That's
I
it.
thought we were doing a cooking show.
So we solicited questions
Yes, we did.
about this book. I don't know if people read your book already.
wow.
Is that possible?
It's conceivable.
I'm looking at the questions.
I just know
have
he's got a
looked
fan base out there.
He
We
does,
know.
and there is several of the questions of people who have already. They say in your book.
Right, okay, so Brian.
Look at this one right here. Your book, Until the End of Time, brings me to the conclusion.
Wow.
Look at that. So there you go.
All
man.
right. So this is the Venn diagram that overlaps his fan base with our viewers.
There you go.
Yeah.
Because we solicited it from our
For
viewers.
your base.
just so
Yeah,
you
great.
know.
There you go.
So
That's
our
right.
people, your people.
I love that.
All right, so Chuck, you got the questions.
Yes.
Just remind everybody how this works. It's Cosmic Queries, and these are solicited from our fan base.
That's right.
I have not seen them. Certainly our guest hasn't.
That's right.
Chuck, you might have seen them, and you
I
have sorted
read them before. And
And Brian Greene and I have very strong scientific overlap, but we're going to get his view on this, and I'll just sit back and listen. And if he's full of shit, I'll tell you.
No, you won't. His guy will not sit back and
There you
listen.
go.
I've never heard that before.
that was funny.
No, plus, I should have said it differently.
No, you won't.
Brian Greene knows almost all the astrophysics I know, and I only know some of the physics he knows.
Nice.
So he can take my physics to new places.
That's very gracious. I don't know if it's true, but it's very gracious. Thank you.
And he's a good mathematician too.
All right.
Yeah.
I mean, I'm going to say yes to that because he's an astrophysicist and a physicist.
Math is a language
is kinda,
of the universe,
Right. Yeah.
in which he is fluent.
Very cool.
I'm delighted to have an all-time friend and colleague. Okay.
All right.
So let's
well,
do this.
Let's do this. And as usual, we always start with a Patreon question, a question from our Patreon patron.
Oh, wait. Excuse me.
Go ahead.
Brian Greene is professor of physics at Columbia University.
Wow.
And also joint appointed in the Department of Mathematics.
That's good.
Wow.
Yeah.
And he and his spouse co-founded the World Science Festival here in New York City every year, where science and art and music come together to celebrate science.
Wow.
That's right.
He does this.
That is incredible.
He's not just some person who's sitting between us right now.
right.
This is Brian
I mean, he
Greene.
is still that.
He's still. I didn't want to undo the fact
Yeah.
he's a person
Let's
sitting between
not
us.
demote him from personhood.
Okay. And I think this is his fourth book.
Yes, right.
Okay. And his first book that anyone knows about was a mega bestseller, which was
The Elegant Universe.
The Elegant Universe. And he's one of our leading string theorists. And this was a way to share not only the frontier of his research with all the rest of us, give us a sense of hope that maybe one day we'll understand everything.
Cool.
Or not.
Or not.
So that was a mega bestseller. And we shared publishers back then. We had the same publisher.
Oh, Norton? You
No,
were-
with W.W. Norton.
Nice,
Then he got
yeah.
so famous, he found another publisher. And then he published another book after that and didn't do as well as the first book. Okay? I just want to just hang some publisher.
You're just
dirty
giving your
laundry-
publisher some cred right now.
Dirty laundry out here.
There you go.
Okay. Brian Greene, Alfred Knopf, publisher. Let's do this.
All right, here we go. As I said, we always start with a Patreon patron because they give us money. And this is Michael Tobias. He says, "Hello, Neil and Brian. I often wonder how far we will journey through space within our lifetime. Will we be able to achieve interstellar travel, or will the human race go extinct before we have the opportunity and technology? Now, he started off with our lifetime, but I think he means the lifetime of the species of human beings. Because our lifetime, the answer is no. And I am not an astrophysicist at all.
Okay, well, we're done with that. Next question.
No, but within the lifetime of the human species. First of all, what is the lifetime of the human species? What would that be?
A few million years.
Few million?
Well, that's a guess, right?
Well, if you look at the
historical
if you
trend,
look at the life expectancy of mammal species,
Yeah, right.
I think 1 in 3 million years, somewhere
Yeah,
around
but
there.
we're so much special, right? I mean, we have this thing on top of our head
We
that
tell
enables us to
ourselves.
figure things out. So either that is going to be our own destruction because we can build things that can kill ourselves, or we'll be able to figure out a way of living beyond the traditional lifetime of many species. So unclear. But if you take...
Well, let me add to that question.
Yeah.
There's what's possible in the laws of physics, and there's what's within reach with our engineering.
Absolutely.
So give me your read on that.
Well, the laws of physics constrain any speed of any spacecraft traveling through space to be less than the speed of light. So if you're not going to play games with imagining that we can actually warp the fabric of space and
That's not playing games. That's real.
Yeah, well, it's unclear that we'll be able to achieve that.
It's real in every movie I've ever seen.
I agree. But taking the speed of a craft to be less than the speed of light, then achieving great space travel is challenging, right? Now, the weird thing is, because time slows down when you have a spacecraft or a clock of any sort that's in motion, you could have a spacecraft going out near the speed of light, and we on Earth would watch its clock, and its clock would be ticking off time so slowly that to the person on the ship, they would be able to go much further than we would think they would be able to if we didn't take that into account.
Right. Okay.
So we could send, some intrepid Voyager out into space, and they could go
And near the speed of light.
Near the speed of light, and they could go arbitrarily far in their lifetime. Yes. So
Then they come back home, and everyone would have forgotten about him because hundreds of thousands of years would have passed.
or millions or billions of years. He was absolutely right. Yeah.
Right.
Yeah.
So that's not what people are imagining when they're thinking of space travel.
No. I mean, so...
But it really matters, if we were to take, a group of our species and send them out into space, it really would be within their lifetime that they'd be able to, according to laws of physics, go arbitrarily far.
Right.
And it's kind of...
It's,
now, you're right. The people back on Earth, they perhaps would be long extinct.
Okay.
Wow.
Imagine. You come back and your
come back.
species isn't even around.
Right.
Yeah.
And the roaches took over. And the rats.
Right.
Yeah.
And they say, wait a minute. You come back. And there's a museum that the rats have, and they're the skeletons of humans there.
Right.
That long ago, it's terrorized the...
Or they could even have, an homage, an exhibit to the spacecraft that left, 100,000 or a million years ago, and you can sort of see the origin of your own trip.
Man.
That's kind of cool, though. I mean, you could actually...
Okay, so you can, but no one else can really participate in that.
Unless they're part of the literal journey itself.
Right. Good answer.
So now what about this in terms of... When you say you put these people on a ship, all right? So you take a colony of people, you put them on a ship, and now they go and they're looking for some place to live, and now you're just seeding the universe, or at least another part of our galaxy, because you can't really say the universe,
Milky Way.
The Milky Way, because we're not going to. How long would it take us to get out of the Milky Way?
Well, millions of years to the nearest galaxy.
Right, there you go.
Right.
So, but. Would that?
Well, sorry.
Well, it's hundreds of thousands.
Right. So
light
let's
years
get the numbers right. So our galaxy is about 100,000 light years across. So if we watch you travel at the speed of light, it'll take us 100,000 years to observe that. But you could live an arbitrarily short amount of time, depending on how fast you're going. So that being said, you in principle could go to the Andromeda galaxy, 2 million light years away.
Right.
We are long dead
gone
here, maybe, and unless we're smart as Brian wants to believe we are. And so, yeah. So you could go to another galaxy. But in practice, you want to pass by stars, not the void of empty intergalactic space.
Exactly, right.
Right.
Yeah, you want to go someplace where there is something.
But Brian's point that I take to heart is when I think of these ships, I think that they're generational ships, and they have to be really fertile people, make babies grow up. But what was odd is you will be giving birth to children who will never have known Earth.
Yeah.
And that's kind of diabolical to me because they would not have had free choice to have taken that trip. Do you have any moral sense?
Well, I don't think any of us have free choice or free will. So if you
Well,
want to
that's
get into
another-
that
that's
part
another-
of the conversation,
that's another thing.
we can go there.
Okay, let's just pull out 2 of those worms from that can. Wow! Holy moly! All right, we'll get back to that.
I can't.
Yeah, that's a big one right there.
I don't have a certain bandwidth.
Okay. All right, so let me ask you. And
No,
maybe-
I'm glad to be reminded that you can send a colony of people,
Right.
and they can get anywhere they want in their lifetime,
Yeah.
provided they travel fast enough. Yeah.
So now let me ask you this. Let's say they want to they're going to go someplace even further, right? We're talking about true interstellar travel, right?
Well, no, intergalactic. at that level.
Intergalactic.
Yeah.
Because they're going to another galaxy, all right? And then they're coming back, okay? And they have kids and kids. What would that do? And maybe this is outside of your purview. I don't know. What would that do to us as a species? Would they be that much different from not having any of the effects of being on this spinning rock going around this little teeny star that we live in right now?
That's beyond my purview.
No, I would say that it is possible to speciate. One of the ways you split a species is you strand a variety of yourself in a place, and then there's no more communication. That's why every freaking animal looks so different in Australia. Okay?
But you still need sufficient time during their isolated periods. And in this case, it could only be even a handful of generations, right?
Right.
Well, not only the
but
time-
there still would be generations, as you said, who would never have experienced life on planet Earth.
But you also need pressure to select against some features and promote others, so that those features then become something else that are not recognizable to where you came from.
Okay,
So,
I got you.
So you need that. And if that ship is exactly the environment that Earth
Right.
has always been and always will
be. If you
be.
create 1G and you do all this
Yeah,
stuff,
yeah,
you're
yeah.
not really creating a circumstance where there's a pressure to.
a pressure.
But if you create a reality show where it's Survivor on the ship, right, and then you have artificial pressures, you could drive the species
wow.
into some different places.
That's kind of wild.
Yeah.
I think we just
So
came
it
up with-
wouldn't be natural selection, it'd be artificial selection.
Yeah, that's right. You just eject them from the ship if they.
All right, we're gonna space you. All right,
next question.
Let's do the next question. All right, here we go. This is Cheyenne Leo, who is also from Patreon.
Cheyenne Leo, that's
Yes.
a nice name. I like that.
Hello, Mr. Greene. I hail from Canada, and I love your books. I've been wondering lately, what is time made of? I might be a little out there, but I was thinking that it must be made of something because presumably it was created in the Big Bang and it interacts with things like light and gravity. Light takes time to get there, gravity slows it down in extreme circumstances, etc., etc. So, if it can interact with other forces, shouldn't it be made of something?
Love that
It's
question.
a great question.
Yeah, when is something more than just an idea? When does it become a thing?
Well, this is an idea that is starting to become a thing right now. So it's certainly the case that the intuition of the question is right on target. When we look at ordinary material objects in the real world, they are made of stuff. They're made of molecules, made of atoms, made of subatomic particles. Could that idea be relevant for space and time themselves? And people have thought about this for a long time, but recently there have been developments in a variety of fields, string theory being one of them, where we're starting to catch a glimpse of what the ingredients of space and time might actually be. And in fact, there's work that's being done that shows
You're not talking about a time particle.
not really a time particle per se, but it's easier to talk about this in space, even though space and time are really the same thing. But we have some evidence that space itself may be stitched by the threads of quantum entanglement. So this idea of quantum entanglement that links together distant objects in a way that makes it appear as though they're right next to each other in terms of their physical properties. It may be that the threads of quantum entanglement are the stitches in the fabric of space-time itself.
Is this where you get to the idea that in the distant future, where dark energy accelerates us ever greater, that it might accelerate us faster than quantum phenomenon can keep up, creating a tear in the fabric of space-time?
Yeah, and in fact, you don't even need to know about the ingredients in the fabric of space-time to come to that conclusion.
You didn't pause when I said that. That means it could really happen.
Yes, so the idea that the dark energy might get stronger over time. So right now we all know that there is dark energy pushing the distant
We all know.
galaxies away.
We all know.
Everyone,
Everybody
we've
knows
spoken about this before.
We
You've shown
actually
me.
have.
Yeah,
We actually have spoken about this before.
Exactly. Right. So, but it's possible that dark energy gains strength over time, which means that it would not only drive the distant galaxies away ever more quickly, but it would start to drive even planets away from their stars, and it would even drive electrons away from the nucleus of atoms, which would rip matter apart. And yes, you're right. Depending on the very nature of space-time, it could be that this dark energy growing over time might sunder space itself, might rip the fabric of space apart.
And then
That's amazing. You're talking about the actual tearing of the universe itself.
I don't even want to think
Now
about that.
Now I should point out that since you brought up the tearing of the fabric of space, a paper that I wrote with a couple of colleagues years ago was the first mathematical demonstration within string theory that the fabric of space can rip apart in a manner that would not yield a catastrophe. The fabric of space would repair itself, and it would just be a new behavior within the repertoire of things that space can accomplish that Einstein would never have thought of. But Einstein didn't think about quantum mechanics and the general theory of relativity. And when you unite them, as string theory does, you get new things that space and time can do. And one of them may be tearing apart.
And it repairs itself.
And it repairs itself, so it may not be as catastrophic as you
ointment
think.
for that. Ointment.
We have a salve. Put some ice on it.
But actually, it's not so much a salve. The strings in string theory can surround the tear and form more of a Band-Aid. So it's more that the strings form a Band-Aid that protects us from the rip in the fabric of space.
But see,
and there's math behind this. It's not like
I was going to say, because that
you
is...
look very skeptical
I'm
at
still.
this.
I did too, because that sounds
And just because it's math, don't hide behind this math.
I'm not
behind
hiding.
it.
I'm just trying to let
I'm just
you
saying,
know.
math can talk about some crazy stuff that had nothing to do with reality, and you know it. Don't tell me there's math behind it.
Of course.
So therefore,
but this emerges right from the most natural interpretation of the equations of string theory. So I'm not standing on my head to make this happen.
okay.
Okay.
That's an important point.
Yeah.
It is.
Because there's a lot of stuff that we think about where you have to go out in left field to try to get the explanation. But if this flows out of your stuff naturally, it's a beautiful thing.
Yeah.
Very cool,
Can I tell
man.
you what else happens?
Oh, please.
Black holes shrink down to a very small size, very small mass, and they transmute into elementary particles. So black holes that you normally think as being kind of this big thing out in the cosmos, different from the fundamental constituents of matter, when space rips, the process that repairs it involves black holes turning into particles.
See, now he just made that
Yeah,
one up. No, you had me until
I was
the
gonna
universe
say.
repairs itself.
I don't make anything.
No.
No, black holes are the doctors and the nurses. No, I'm sorry. No, you full of shit now.
Oh, man. Oh.
All right, no, we got to wrap this segment.
Oh, we got to wrap this
I know, I'm
All
sorry.
right,
We're taking too long to answer these questions.
No, we're not. This is
Okay.
great stuff.
When we come back,
Oh, I wish you were here every day, Brian. Oh, that was
more
amazing.
cosmic queries until the end of time. Questions from the heart of the cosmos when we return.
The Great Courses Plus is a subscription on-demand video learning service with top-notch lectures and courses from top professors from the Ivy League and other great universities globally, and experts from places like National Geographic, the Smithsonian, and the Culinary Institute of America. Through your subscription, you get access to a huge library of over 11,000 video lectures about anything that interests you, from science, math, history, literature, even how to cook, play chess, or become a better photographer. And we know you're intellectually curious, so we know you're going to love it. Speaking of better photography, I've always wanted to take better pictures, and thanks to the Great Courses Plus, that's happening. I am taking the fundamentals of photography with Joel Satori, a pro photog from National Geographic. I'm learning about lighting and composition, and most of all, how to take interesting photos. Stream and enjoy from your TV, your laptop, your tablet, your phone, or through any web browser by using the Great Courses Plus app. Learn at your own pace, when and where you want. Now, the Great Courses Plus is giving you a great offer of a free trial. Show your support for StarTalk Radio by subscribing to the Great Courses Plus. Please visit thegreatcoursesplus.com/StarTalkRadio. Click on the link in the description below to start your free trial today.
We're back. Star Talk. Cosmic Queries. We've got Brian Greene here,
Yes.
the one, the only, longtime friend, colleague. Love this man to death. He's been a friend of StarTalk from the beginning. From the beginning. This is not his first rodeo with us here. So, Brian, congratulations on your 4th book.
Thank you.
And got a great write-up in the New York Times, very enthusiastic write-up. And even when he was criticizing it, he was praising it.
Yeah, right.
It's like, oh, it got complicated, but it needed that, and I kind of liked it, and it got me into it. You know, it was like one of those kind of things.
So who actually reviews your books? I'm serious. Like, you two guys, you write these books. Who is it that sits down and says, okay, let me go through here
It's his
and
mom.
see Brian's mother. That's
Just
so
intermittent
funny.
employee for the New York Times.
Yes. Son, I have to tell you, I don't know about this whole thing about black holes and particles. So, no, really, who is it? I mean,
Well, they're
I would say
science
there's not a
editors.
lot of people that can do that.
They're science editors.
okay.
That's their job.
All right.
And if they can't handle it, then they don't review it. There are plenty of newspapers don't review science books.
Oh, actually, the number of reviews of science books is going down
Oh.
because newspapers are really winnowing the
Yeah,
staff. of the people who do
they're
it.
cutting
Yeah.
their staff so
Yeah.
they can't afford it. Wow.
So this, just to give him credit, because he's in the club. Dennis Overby, longtime science writer and editor.
One of
for
the best, really.
for the New York Times, and he leans cosmological. Although when we demoted Pluto here, he wanted to dip into that. When I said, this is not your beat, you know, this is too nearby for you. But I think he wanted some Pluto street cred.
Right.
So he did a little Pluto article on our demotion.
And was he for or against your postulate?
He was antagonistic. Yes.
Oh, okay.
Yeah.
All right, gotcha.
But anyhow, he's a longtime editor, and he has a book of his own.
Oh, yeah.
So the real meta
So
question
did
is,
you
who
two
reviews
actually review his book?
I think he wrote a book, The Lonely Hearts of the Cosmos,
Hearts of the Cosmos.
which was about 2 astronomers trying to find the scale of the universe. Was that the book I'm remembering?
I don't remember the details.
Okay, but it was biographical.
Okay.
Astronomers who had access to big telescopes.
All right.
And you're there at night looking up at the night sky with the telescope, and nobody else. Lonely Hearts of the Cosmos.
Oh,
Yeah.
okay, that sounds about right. Okay, no, I'm joking.
Oh,
All right,
what do you have?
here we go. Let's get back to our questions. This is CS Toe
Chuck, hold
1.
that lower so people can see your beautiful face.
I'm sorry. Here we go.
There you
CS Toe 1. I forgot we're on camera too. Hey, do you think the laws of physics are finite and knowable? Can we ever fully understand the universe in its entirety? If so, what forces might we be able to manipulate that are beyond us now? Ooh. That's a very, very cool question.
No, it's a deep question.
Yeah, it really
because,
is.
Look, you look around the world and there are intelligent beings walking around, dogs, right? And they don't, we think, understand the general theory of relativity or quantum mechanics. So these are intelligent
Snoopy.
brains. Although when I say that, I always think the dogs are about there barking and say, he thinks we don't understand general relativity. But seeing if that's really the case, then why do we think that the human brain would be able to understand it all? We may have limitations on the deep truths that we're able to grasp. Now, having said that, there's no evidence that there's any limit to what we can figure out. We haven't hit the wall. Right, we did develop quantum mechanics. We did develop relativity.
Wait.
You know,
Wait. You and your compatriots have been at this string theory thing for 30 years.
Yeah, here we go.
Maybe.
Here we go.
Maybe that's the wall.
It could be.
Maybe you guys aren't smart enough. You found the wall.
But here's what I would say to that.
Let me hold up a mirror to you here,
Yeah,
okay?
but let
Who's
me-
the one who can't find, who's at the edge of the wall?
See, but that would only be the case if we were sitting here saying we can't make any progress in understanding the mathematics of string
Right.
theory.
And
we're
then-
making incredible progress, but the thing is, and the part that you're responding to, which is completely justified, we haven't been able to make contact with observation or experiment. But that's not all that surprising when you're dealing with a theory whose energy scale is like 10 to the 15, 10 to the 16 times greater than that of the Large Hadron Collider, a most powerful machine in Geneva, Switzerland. So I agree that we have hit roadblocks, but it's not us theorists, it's the experimenters.
Oh!
There you go. And if I might chime in here,
Smackdown!
if I might
Ooh.
chime in here, let me just add.
That's the dog saying, we have the solution, but you just,
There's your answer, guys.
you're neutering us and you're taking us to, and you're feeding me Alpo. I don't know.
Okay, cool, man. Oh, that's a great
Wait,
answer.
so-
That's a great answer.
Wait. So let me
But go ahead.
let me give a nuance to that question and hand it back to him.
All right.
Okay. do you believe there may be missing laws of physics that'll help us get further, or that kind of all the laws of physics are there? We just need to be more creative with what we've got.
Yeah, I think it would be hubris.
That's a little bit of that.
Yeah,
but-
it is. It is.
It's a different tact.
Yeah, to think that we really have it right now would be sort of the classic act of hubris, right? I mean, every time we thought we figured it all out, there was a new law, there was a new particle, there was something else to find. So I would imagine at sufficiently high energy scales, we're going to find new stuff. New particles.
New entry scales would be beyond where anyone has gone before.
Yeah, so right now...
To boldly go.
Yeah, so let's say we've basically gone on the order of 10,000 times the mass of a proton, roughly speaking. Energy scale. And we haven't found anything new yet. But I would imagine that between that scale and the so-called Planck scale, which is where the fundamental laws of quantum mechanics and gravity come together, that's 10 to the 19 times the mass of a proton. So that's 19 orders of magnitude bigger than a proton, and we've only gone up to sort of 4 orders of magnitude bigger than a proton. So in that range, I suspect there's going to be something new to be found.
Okay. Interesting. Because just in all fairness to those who've come before us, they would be working in a tabletop. Right, and there'd be some phenomenon they don't understand, and then they'd experiment with it, and then they isolate it and name it and characterize it and mathematize it.
Yes.
And so our basic known 4 forces of nature come out of that kind of experiment.
Exactly.
Kind of tabletop plus simple particle accelerators, right?
And astronomical observations.
And observations. So
Yeah.
what you're saying is that's a regime that manifested some aspects of nature that we have figured out in a tidy way.
Yeah.
But there could be bigger questions we don't even get to yet because we haven't tested the regime, and that regime is not on our tabletop.
Exactly.
Okay.
Yeah.
That means the future of physics is big money, big accelerators.
That is one
longer
way.
The lone candle
It's
burning.
that, but I also like to think that if we're sufficiently clever, we might find indirect ways of probing realms that you think would require that big machine, but maybe we can be smarter about it.
Okay. All right.
On Star Trek, it's just all computer simulations. So,
By the way, just as a signal to my people being clever, it was, how are you going to put a big telescope in orbit? Well, you can't make a rocket that wide. No, so you
Build it.
let's build it.
Yeah.
Well, you can build it in space,
Yeah.
or you can get a mirror that unfurls.
Right.
All of a sudden, the engineers say, hey, I got this.
Right.
Let me be clever and figure it out.
Yeah.
So we've actually overcome many challenges that previously were considered intractable just by clever people.
Yeah, exactly.
I'm echoing your point.
Yeah,
Cool.
exactly right.
That is super cool, super cool, super cool. All right, here we go. This is Jane 9117 says, finding/creating your own meaning is fine, but objectively, what do you think, Brian, is the actual meaning of this creation?
Yeah.
Ooh.
Yeah, that
Because
that
meaning
comes
is
right.
that's a big part of where you try to go in this book.
Yeah. And the answer that I give to that question, which I develop completely and more fully, I should say, not completely in the book, is that there is no ultimate meaning floating out there in the void, right? Throughout these,
I got to go through all these pages and to find out that there's no
I'm
meaning.
I'm going to give you the.
I got to read this for you to tell me there's no meaning.
Cliff notes right here. So the cliff notes are that we are the product of the mindless, purposeless laws of physics. We are all just bags of particles governed by those ironclad
Ectoplasm.
mathematical. That's it. And what we have the capacity to do, which is remarkable, is impose order, impose coherence, impose purpose and meaning on the external world and the internal conscious experience. And so it's not as though they're two things. The real answer that's floating out there in the void awaiting our discovery and sort of the internal one that we manufacture, it is only the internal one that we manufacture because there is nothing else.
How do you know this?
I don't know this beyond my experience in a lifetime of working with the laws of nature, the particles of nature, and trying to give explanations for the things that we observe in the external world.
So the
It could be-
particles are your gods.
there is a place for religion.
You need to answer
So
that
if you really,
question way faster
no,
than that.
No,
The particles are your gods. Oh, well.
No, if you really want to go there.
Well, let me think about it.
No.
My altar has some neutrinos on it, but
Yeah. No, but honestly, seriously, I do think there's a role for religion that some of our colleagues step on and dismiss out of hand entirely.
And what would that be?
Well, it's not to understand the external world. No one can use any religious doctrine to calculate the electron's magnetic moment to 9 decimal places, which is what we can do routinely with quantum field theory.
Okay.
But if you think about religion and the spiritual journey as something that doesn't illuminate the external world, but rather the internal
Which
world
many
of conscious
people
experience.
go towards for meaning in life.
Yes, exactly. Then there is a role for it. And you don't judge it by whether it can explain the external world. That's not what it's meant to do. You judge it by whether it is a satisfying way of trying to understand your place in the universe.
90% of religious people would say that. The other 10% who are fundamentalists,
Yeah, of course, go different
get
direction.
their science out of the Bible.
I agree.
Right.
And
But
that's problematic.
Enlightened religious people are where you're coming from.
I agree.
That's very good.
That was a little journey. I liked it.
I
Man.
still think he's got an altar in his home.
a
I gotta-
neutrino altar.
I'm pretty sure. he sacrifices to the particle gods. I'm pretty sure. I'm pretty sure about that.
All right. Okay. Let's move on to Lee Bird. Okay. So Lee Bird from Facebook says, "Hello, Dr. Tyson and Dr. Greene. My wife has asked, where does our universe end? Not how, but where does our universe end? And I would like to say, are there more than one ending? Is there an ending and then more endings? Are there levels of
But that's a
endings?
time ending rather than a place ending.
Well, that's what I'm saying.
All right.
It's-
But is this a place ending? That's what I'm hearing.
that's a
about
place.
him.
No,
You think it's a
Oh,
time
where?
ending?
Oh, no, where was the place?
So there's a place
Yeah.
ending.
Where?
But
Yeah. Yeah, so it's
Where's the sign that says?
says stop.
Stop
Can't
here.
go any further. And-
Bridges out.
And look, the quick answer is we don't know.
Okay.
But the possibilities are space could go on infinitely far, in which case there never would be an end. That's a strange idea to us beings that live in a finite environment, but nevertheless, the math allows that as a real possibility.
Oh, cool.
Or space could be curved, which means you could go out in that direction and ultimately circle back and return to your starting point. So there again wouldn't be an end,
Right.
but nevertheless, the space would be finite in its extent.
Right.
So these are sort of two big
Well, so you could
possibilities
travel
people think
An
about.
infinitely finite space.
Yeah, an infinite. Yeah,
You could go infinitely far, but it would be a finite extent.
finite,
Yes, right.
like the surface of the Earth.
Yeah, like the surface of the Earth. Exactly.
I can tell you this.
Yes.
It will offer some insight. We look out to the edge of the observable universe.
Okay.
And we see light that has been traveling for 13.8 billion years.
Okay.
That gives us evidence of the Big Bang for that part of the universe experiencing it at the time it emitted that light. That horizon continues to push out.
Right.
As long as we keep seeing evidence of the Big Bang, we are still moving into a universe that's our whole.
Yep.
Right.
Imagine the day where that horizon washes over the last bit of matter that experienced the Big Bang. Then the information coming to us about the Big Bang ceases. And all of what we know of cosmology would have no data set at that point. And at that point, you're basically the moving horizon, which gets 1 light year away from us per year,
Right.
at that speed, would have overtaken the last matter of the universe, and that would be the edge of the universe. Do you agree with that?
Well, there's a version of that I think I can agree with more precisely, which is
I meant no, but
That was a
Yeah.
very,
Well,
he's
very
a guest on
diplomatic
my
no
show.
there.
He's a guest. He's got to be polite.
Wait, by the way, I am taking notes. I got to learn to talk to my wife like this. I have got to learn how to talk to her like this. It's like, would you agree? Well, there's a version that I would agree with more precisely, dear. You know,
Everything but the deer.
Exactly.
He didn't say
He didn't say
deer.
deer,
Can
but
I get a deer
yeah,
out of that,
At least
please?
throw the brother a deer. At least.
So even right now, with the accelerated expansion of space, we can do calculations that show us quite clearly that the distant galaxies that we have used to figure out that space is expanding, they are going to disappear over the cosmological horizon. We will not be able to see them in roughly 100 billion or a trillion years.
Okay.
So the evidence that we've used to even figure out that space is expanding
It's going away.
is going away.
Right.
Okay.
Which is a strange thing because we
So what you're
usually
saying is the
imagine-
expansion will overtake
Yeah.
the matter that is giving us this information will overtake
Yeah.
the moving horizon.
Yes.
And then it's a moot point. At
Yeah,
that,
yeah.
right,
It'll
okay.
basically drop over a cliff at the edge of space, which is the horizon, because it's moving away so quickly.
Yeah.
You're
exactly
outrunning
right.
your headlights.
Yeah.
Ooh.
That's what you're doing.
Yeah.
Yeah, that's cool, man.
Yeah.
All right.
Okay, no, we got to take a break.
Oh, really?
I know.
This is so good.
I know.
I forgot we were doing a show.
I know, right? Plus, I did still get my deer out of that. Deer.
That's a different marriage.
That's a real one.
Marriage.
That's
That's a real marriage.
All right, Star Talk, Cosmic Queries, Brian Greene, Chuck Nice. We'll be right back. Star Talk, we're back. Cosmic Queries until the end of time. Search for meaning in the universe. And Brian Greene goes there. He does. In how many pages, Brian?
Oh, it's only 300. A lot of endnotes. That's why it looks so thick.
Oh, there you go.
Yeah,
There you
yeah,
go. Well, that's a nice picture of you.
Oh, thank you.
Yeah, nice picture.
Oh, wow, and it's recent and handsome.
Yeah, it was
Good
5
It's
minutes
not,
ago.
Not like a Tinder picture. Like, wait a minute, this dude is 23.
So, Chuck, give us the questions.
All right.
This is our last segment. See how many we can squeeze in.
Real quick, we'll get quick. Let me just ask a quick question for myself. All right, we're able. This is hypothetical because we're not able to, but we're able to get beyond this horizon that you were talked about. We're able to observe that there, whatever, right? But now we are outside of the universe that was created at the Big Bang. What is time in that place?
Well, it could be the same as time here. So that cosmological horizon is, as Neil was pointing out, just the distance that we can possibly see because light has had the time to travel from it to us since the Big Bang. But it could be that time applies throughout this realm of space, and it could be that it looks out there much like it looks in here. It's not as though you pass through it and you've been in some entirely new domain. However, it's possible that it could be different. Since we've never been there, the math suggests that it will be the same. But were it different, that would be shocking and wonderful.
Wait, but Brian, let me take issue with that.
Yeah, please.
The horizon is not a real place.
Yeah.
It's just a property of where we are and the speed of light.
Yes.
So when
that's what I meant.
Well,
but,
when I'm a ship at sea, and I go to my horizon, whatever 10 miles away, now I have a new horizon, and I'm still at sea.
You're still at sea.
Exactly.
So why are you telling me something different is going to happen?
That's my point. I believe that will be the case in the universe. But it's also conceivable.
That is not what he said.
No, but it's conceivable. You would agree that when you take your ship, it's possible that when you reach your current horizon, it could be that things are completely different. It could be the dragons are there. It could be the gates of hell.
There'd be dragons.
You've never been there.
Or you'd have to presume that at exactly that distance, and you were in the middle of where all those dragons were, and that's kind of
special space.
That's a very special space. I can't.
But that was the point. So
I can't go along with that.
Yeah. So if I didn't say it clearly, I suspect,
if you
and
said
the
it
math
incorrectly,
strongly argues that it will be the same out there.
Fine.
But it's conceivable.
It's conceivable
that it would be different.
All right.
Yeah.
But I get what I really get out of that, and maybe it just help me out here. What you're saying then is what we are seeing is a reference. That's what we're seeing.
Yeah.
We're not really seeing an edge. We're not seeing.
Right.
We're seeing a reference is what we're seeing.
Any more than a ship at sea. That's not the edge of the Earth. You can think it's the edge of the Earth, and it might be the edge of the Earth. It probably isn't.
However,
getting too much time to think.
I should point out. I should point out
Here.
that in a universe where the spatial expansion is accelerating, that cosmological horizon would actually have a temperature. You're right. It's not a real location in space, but from that spot, we would have heat emerging that would give a background temperature that at the moment would be about 10 to the minus 30 Kelvin. So it actually has a physical presence, even though it is in some sense just a reference.
It's a thing to measure.
I love that.
A thing to measure.
Yeah.
That is awesome.
I love things to measure.
Moreover, can I point out, just since we're going on this tangent, that temperature that comes from that distant cosmological horizon may imperil the future of thought itself. So one of the things I describe in the book is that in the far future,
that's where the book ends. The thought ends.
Yeah, it is.
I don't hit my limits.
It's close. It's the end of thought.
It ends like this. I'm cold.
Never here's the idea.
Go
So
ahead.
any cogitating being, through the act of thought, has to release heat, right?
Yes.
Second law of thermodynamics.
Yeah.
And if it's the case that cogitating being can't release its heat, it will burn up. And because of the heat emitted by that distant cosmological horizon, in the far future, a cogitating being will not be able to release that heat. And if it thinks one more thought...
But that's not very much heat.
I know. But in the far future...
That's all you got.
That's all you got.
Oh, that's all you got.
Yeah.
So you're saying Ooh, this is scary. Don't tell me this.
Yeah.
Oh, now I'm sad.
Yeah.
Let me
now
repeat
you're going to read the book.
No, okay.
Yeah.
No. Now let me repeat what I think you said.
Yeah.
That every act of thinking is a thermodynamic electrochemical process, as far as we know.
Yeah.
Okay? So that creates heat that needs to dissipate so that you can have your next thought.
Yeah.
If the thermal bath in which you were immersed has a greater temperature than the temperature of your thoughts, then your thoughts will back up and overheat, and you can't sustain that.
Yeah, that's the basic
Like
idea.
an overloading phaser.
Yeah.
Yes.
Yeah.
Yeah,
Very
but now
good.
It's the brain
it's
of
the
the
brain
thinking
that's
being.
actually doing
So
it.
it tries to
Forgot
think.
all about the overload, and it
explodes.
self-destructs.
Yeah, self-destructs.
Wow. All right, let's get back to this. Okay, because
All right.
we're short on time. Okay, all right.
All right, what do you got?
Here we go. This is Juan on Instagram. 9Juan. He says, "Hi Neil and Brian."
He's not 911. It's just...
It is 911.
It is?
It is.
Okay.
That is
All right.
You were absolutely right. It's 911. And he goes, "Hi Neil and Brian and maybe Chuck. My question is the following: hypothetically, if we were living in a universe where we can increase or lower the entropy, would it be possible to travel in time?" Greetings from Montreal. I really love the podcast, and it makes my commute all.
So let me
the
reshape that so more
so
people
you
can
can
be part of that.
understand.
So as you know, and as you've written, the increase of entropy is one of the arrows of time. So if we somehow had control over entropy in the universe to reverse it, will that imbue us with powers over the arrow of time?
I don't think so. So you're right. We often do think about entropy and its relentless increase as an arrow of time. But if it were to reverse itself, time would still carry on in the direction that it was always traveling. We would just see some weird things happening in the environment around us. We might see, for instance, eggs unbreak or candles unburn. But it wouldn't be time going backward. It'd be those physical
phenomenon.
processes going backwards. Yeah.
Okay. So
Now, if everything went backwards, that would be something else. But that's not what the question is. It's just we're able to reduce entropy in some regions.
okay, so if we're able to reduce entropy of the universe, because we know we can do it locally, that's what life is.
Yeah.
Life is life is organized matter, so it has lower entropy than it would otherwise have if life did not form. And we're using energy from the sun, basically, to do this. So if we somehow did have power over entropy of the entire universe, do you think that would have any consequences at all?
Well, yeah. I mean, it would radically change our predictions for what will happen in the far future.
That's the
Okay.
Yeah. Things that our understanding of nature is so intertwined with an increase in entropy that if entropy systemically decreased, we'd have to rethink what was cause and what was effect.
That's right. And we'd have to rethink where we are headed in the far future.
Yeah, okay.
Dude, that's really cool. Okay. All right, let's do this one.
And I have to rewrite one of the chapters of my book.
Team Forsyth Observatory on Instagram would like to know, hello, Neil, Brian, and Chuck. What do you all believe would be the world's religion's response when we're contacted from another civilization outside of our own existence?
Give it to me. What
There
do
you
you have?
go.
Yeah, I don't think it will make all that much of a difference. I think the nature of reality for us scientists would change completely, because now we'd have a second instantiation of life out there in the universe, which would be a radical moment. But I think for the
Not
world's
just life,
religions,
but intelligent life.
Well, because
Oh,
they're here.
even better, yeah. But for the world's religions, I don't think that there'd be much of a difference, because they have a certain perspective on where we've come from and why we're here and what we're doing. And I don't think that the existence of additional intelligent life would really change things in any substantial way.
Oh, okay. Let me
So here's
let me do this for both of you. Here's the deal. That same thing.
Yeah.
But now, here's the deal. Those beings tell us, we put you here. Now, what do the religions do?
Well, so there's already religion about that.
What?
They're called the Raelians.
What?
I'm just saying.
Is this true?
Yes.
Is this
Really?
The Raelians. So this religion is a religion where God is not God as imagined in the Hebrew Bible, but God is an intelligent race of aliens that created us.
Really?
And so there's strong overlap with a God, because if a God created us and they're the external thing,
Well, there's a creator.
a
and the whole
creator,
deal.
right? So
you got that.
alien. So there's a whole religion that's already there. Is my point.
So they would just be like, "Told you."
Exactly. But to your point, there are some religions or some branches of religions where it is very important to them that the universe was created for us and for no other life. They would have an issue with this. But most religions have gotten past that. And religions are more than just belief systems. They're also institutions. And institutions generally have their own survival as a fundamental part of what they do and why they do it.
And moreover, there are so many religions already practiced on planet Earth, and each one needs to deal with the existence of the others.
The other religions.
Other religions, and they're able to do that by virtue of saying ours is a real one and theirs is not. So I think we'd have that same kind of response if aliens came down. But to your point about Ray aliens, if that's the name of it, there's also the simulation hypothesis, right? If we are all just a simulation of future supercomputer, then again, there's a godlike being, the kid in the garage who's fired up the supercomputer, and again, you don't have anything supernatural, and yet we would be the outcome of a creator's desires, wishes, whims, because that kid fired up that simulation.
Okay.
So he has another altar, and as a kid, he prays to the kid god as well as the particle
the
god.
snot-nosed altar. Right, gotcha. All right, let's see if we can get another one in. This is
I think we can.
Oscott. He says from Twitter, since the beginning of our civilization, the human mind and consciousness have evolved so much. Can the human brain figure out the human consciousness? In what ways can we confidently predict that we will acquire the ability to comprehend the majesty of the cosmos?
So do you get into consciousness?
I do. Yeah, there's a whole
focus
on it.
So we got to go quick. What's your take on it?
My take is that consciousness is an exquisite physical process, but nothing more than a physical process. It is simply particles coursing through a gloppy gray structure inside our heads, again, fully determined by physical law.
Do you think it was emergent?
And is the organization? Yes, it certainly emerged by virtue of the organization of this structure inside of our heads. I don't think there's anything else beyond the particles and the laws of physics required for consciousness to exist. I mean, do you?
No, I'm not convinced by so much of what's written about consciousness. I mean, the fact that there's so many books on consciousness and everybody's talking about it means no one knows anything about it. That's the evidence you don't know anything is people keep writing about it, right? How many people are still writing about Einstein's general relativity?
Yeah,
the book is on the shelf.
Of course, yeah.
Right?
Yeah, so it is, but I agree. I think everyone agreed. It is the grand mystery. You know, where does consciousness come from? And many take the approach that we know historically people use with life. People thought vitalism. It couldn't just be particles and the laws of physics. You got to inject something else, a life force.
Right.
Nobody talks that way any longer, right?
Well,
And now
some Christians will talk about a soul.
Right, but few scientists think that way any longer. Similarly, there are some scientists who think you have to inject something into the particles and the forces to get conscious self-awareness. I think 100 or 1,000 or whatever number of years from now, people will look back and smile at how quaint that idea was, but there's nothing more than particles and physical laws.
What was the question about consciousness, though? Did we answer?
Will we be able to understand consciousness and
then
using
majesty.
that be able to understand or comprehend the majesty of the cosmos?
So let me reshape that. So, is there a level of consciousness that awaits us that will enable us to appreciate the cosmos even deeper than we already do?
I certainly hope so.
A level of awareness, I guess.
You know, I think as we learn more about reality, we reshape our sense of who we are and what the grand mysteries of existence are. And I think that's a beautiful journey that we've been on for thousands of years, and it will carry onward.
Ooh, cool. Those are some final thoughts.
Those are very good final thoughts.
Yeah. Brian, you don't come by often enough.
Invite me. I'll be here.
Dear.
We have to write him, dear. We have to invite him more often than the rate at which he writes books. That's the problem. Okay.
There you go.
All right, Brian. Always good to have you,
Thank you, sir.
Chuck.
It's a pleasure.
My boy.
My man.
All right. This has been Cosmic Queries. I'll just have to say it, the Brian Greene edition. All right, Neil deGrasse Tyson here, your personal astrophysicist, as always, bidding you to keep looking up.